Okay, y'all. So we're dealing with imaginary numbers. Hopefully, some of y'all remember this.
I keep getting screwed up on the last.
Yes, Miss Mills. Okay, but let's focus on this one real quick because I just started recording, so I need to start doing this one. Okay, so equations such as x squared plus 1 equals 0 have no real solution, so mathematicians define the imaginary numbers to represent their solutions. Because if we were to work this out, we'd have x squared equals -1, right? Because we would subtract it. So when we would take the square root, we'd have x equals the square root of -1. And does anybody remember what the square root of -1 stands for? It's an imaginary, but I, yes. So the imaginary unit is I. And it's defined as I equals the square root of -1. So this is useful when we're working with square roots of negative numbers. So a pure imaginary number is written in the form AI, where A is the real number and I is the imaginary part. AI. So when we're doing this, step 1, we're going to rewrite the square root of -A as negative square root of -1 times A. And then for step 2, we're going to break down A if it's not a perfect square. So if it's not a perfect square. And we've got all of the perfect squares right up there above the board. Yes. Yes. So, well, I'll show you in a second. But you want to make it where it's literally going to look like this. And that A is going to be a number. So, like square root of -25, and we're going to make it look like square root of -1 times 25. Does that make sense?
Sure.
It will make more sense as we do them. Okay, and now on to the last part, step 3. We're going to simplify the radical and recall that -1 square root is equal to I. Okay. Now, does everybody have that? Does everybody understand? Okay. Now, let's move on to number 1. So, step 1. What? Don't put this in your calculator. We're working it out. Step 1. What's step 1? We're going to rewrite it. So we're rewriting it as square root of -1 times 9. Now, I like to rewrite it where we have 2. Why does that make it easier on us? Because we know the square root of 9 and we know the square root of -1. So, we don't really need to do step 2 because this is not a perfect, this is a perfect square. So there's no need for us to do step 2 because we don't have to break it down like we did the last class. So if we move on to step 3, we know that this is what? Imaginary. And that this is going to be what? 3. Now, this, you do not have to put plus or minus when simplifying an expression. But when we're solving an equation, that's when we put plus or minus. So if you want to write right over here, simplifying Why is it being weird?
Just the.
Sounds like you're coloring fell and not writing down what I'm writing.
I already have it here.
Okay. I'm just writing more, so I was just wondering. Okay. So, when we're simplifying an expression, which this is an expression, there's no need for the plus or minus. No need for it.
So 3i is the answer.
So 3i is our answer. Okay. Does everybody have that? Can I move on to 2?
Yes, ma'am.
Okay. Now, moving along. So, step 1.
Rewrite it.
Let's rewrite it as the square root of -1 times 196. Now, we know the square root of -1 is going to be I, so the square root of 196, is it a perfect square? Go ahead, put it in your calculator. I have my calculator too. Square root of 196, and what is that?
14.
14. So, no need for step 2. We go ahead for step 3. So, 14 I. And that's our answer. No plus or minus, because we're just simplifying an expression. That's all you're doing for now. Because we'll have to, this isn't going to be like any different than what we were doing last class. We're now just adding imaginary numbers. And it's going to be the same exact concept as last class, where we're breaking down the radical. This one is just a little bit easier right now. We start off easy, we go a little harder. Okay, everybody got that? Yes? Okay. Moving on. Step 1. Rewrite it. -1 times 5. We know square root of -1 is I, square root of 5. What are factors of 5?
10, 15, 20.
1 and 5.
Oh.
Factors are multiples that you can multiply to get the number. So, 1 and 5. Neither of those are perfect squares. So, we are just going to have, for the final step 3, we're just going to have I on the outside, and then we're going to be stuck with the square root of 5. So factors are numbers that multiply to get the product.
Wait. That says 1's a perfect square up there.
1 is a perfect square. But then that would mean we just have like a 1 in front of it, but that's understood.
Because it could just be I.
Yeah. So it's just I, square root of 5. Is it lagging? What's it? 1 is a perfect square, but there's no, that's like when you're writing an equation, do you put 1x or do you put x? Okay. Because there's no need for the 1. It's understood. Does that make sense? Square root of 5 couldn't be broken down, but we pulled out the I. Ellen, you got that? Okay. Moving on. Square root of -80. So let's break it down. Why is it being? So we rewrite it as square root of -1 times 80. So, we know square root of -1. So, what are some factors of 80? Now, I want you to take your calculators and I want you to do 80 in your calculator and start dividing it by numbers. So, let's start with 4, okay? It's 20, but we know we can break down 20 into 4 and 5, so that's not going to be it. So, let's go 80 divided by what's the next one?
5.
Y'all, perfect squares. Look at the board. Look up there. Look up there. What's in the middle of the box?
16.
16. Okay, so 80 is divisible by 16 and 5. So 16 and 5 are its factors. Why are we choosing those? 16 is a perfect square, but 5 is not a perfect square. And 5's factors are 1 and 5, and we cannot break those down anymore. So, step 2, which is what we have broken it down. So we know -1, the square root of -1 is going to be I. But if we have square root of 16 and the square root of 5, what is going to be our answer for our step 3? What is the square root of 16? 4. And then we're going to have the I and then square root of 5. Good. And that's our final answer. Does everybody see how we got that? Wonderful. Okay. Now, moving along. Good. What? On which one? Okay, so for this one, step 1, let's break it down. Square root of -1 times 32. Now, we know square root of -1 is going to be I, but we need to break down
8 and 4.
Yeah, I'm going to start writing this part into the blue for step 2. So step 2, we know that that's really bad, is going to be I. But we need to break down 32. So 2 and 16. And why is that our best option, Jacoby?
Yes, there's one that isn't a perfect square. There's one that is.
Yes. So 16 is a perfect square.
8 is a perfect square.
8 is not a perfect square.
4 is, so why is that not?
4 is a perfect square of what? 2 and 2. 8 is not a perfect square because the factors of 8 are 4 and 2 and 1 and 8. And 4 is a perfect square, so if we had all of the, like if we had 4 and 8, if we had 4 times 8, this is a perfect square, but then we would be able to break this down into 4 and 2. So then we would just have 2 times 2 and then the square root of 2. So then we would just have 4 square root of 2, which is what this is up here. Does that make sense?
Yeah.
So we would have times square root of 16 and then times the square root of 2. So step 3, we know we're going to have 4 for the square root of 16, and we're going to have I, and then we're left with the square root of 2. But my biggest thing to let y'all know is that when we're looking at numbers like this that aren't perfect squares, literally take your calculator and start at the closest thing. So like I would take 32 and I would divide it by 25. Okay, that's not right. Okay, so 32 and then go down. Okay, 16. So you want to start at the biggest perfect square, closest perfect square you can, and then go down from there. So I'll show y'all as we go on. We'll have more like that where we can just build off that. But that is our answer. Oh, I was stuck on the thing. But that is our answer. Did that make more sense, Nick? Okay, perfect. Okay. Number 6. So, step 1. I'm going to stop writing the steps. I'm just going to do the colors. So, we're going to have -1 times 192. Now, we know -1 is going to be our I. But what are some things we can break down 192? Or, if you put it in your calculator, is it a perfect square? No, it's not. So let's do 192. Now, divide it by 100. Okay, that's not it. 192 divide by 81. That's not it. 192 divide by 64. Oh, look! 64 and 3. So, so this is going to be I, and then we're going to have 8, and then we're left with the square root of 3. So our final answer is going to be 8I square root of 3. Does everybody see how I got that?
Yeah.
Does that make more sense? Where we take that big number, we just start dividing it by numbers that's smaller than it. 111. So this is one where we're going to have to, sorry, this isn't focusing. Okay, there we go. So this is one where we're having to isolate the x squared. So we subtract 81 from both sides, and so that goes to 0, and we're left with x squared equals -81. What's our second step? We're taking the square root of both sides. So when we take the square root, we're left with x, and then if we have square root of -81, we need to break it down, right? That's our second, or our first real step. So we know that this is going to be I, and the square root of 81 is 9. So our final answer is going to be, plus or minus 9I. So, like I was saying earlier, y'all can just put it in this box, I guess. That works. So, why is it acting like that when I write? When solving equations, use the plus or minus. Okay, so for this one, let's go ahead. We're going to isolate the x squared by subtracting 9 first. 0. So we're going to have 2x squared equals -8. Divide both sides by 2. So we're going to have x squared equals what? -4. So then we take the square root of both sides. So we're going to have x equals, if we break it down like that, we know we're going to have an I, and 2 is going to be plus or minus. So our final answer is going to be plus or minus 2I. Moving on. So Our first step, we need to subtract 15 because we have to isolate the x squared. So that goes to 0. We're left with 4x squared equals what? Negative 24. Then we divide both sides by 4. So we're left with x squared equals what? Negative 6. Now, we take the square root of both sides. Is 6 a perfect square? No. We still need to rewrite this though. Why? Because there's a negative, right? So we need to rewrite it negative 1 and 6. So we know that the square root of negative 1 is going to give us I, and we need to put that plus and minus in front of it, and then we're left with the square root of 6 all equals x. Does that make sense?
Yeah.
So for this one, we just need to subtract the 13 on both sides. Yes. So we're left with x squared equals negative 12. Right? Right. Okay. And then we need to take the square root of both sides. Now, if we break this down into negative 1 times 12, what are the factors of 12?
4, 3.
4 and 3 are going to be our best options. Because if we did 6 and 2, neither of those are perfect squares. And 1 and 12 is not either. So 4 is going to be our perfect square. So we know that this is I. So let's go ahead and put that over here. And we know something's going to be left inside the square root.
4.
So we've got square root of 4 and square root of 2 is going to, 3 is going to give us 12. So square root of 4 is plus or minus 2. And so we're going to have plus or minus 2i on the outside of the square root. And then we're going to have 3 left on the inside. And that is our final answer. Okay, so we're going to start by adding 5 on both sides. So we're going to have 3x squared equals what?
Negative 4, 4.
And we're going to divide both sides by 3.
Negative 147.
So we're going to have x squared equals, you said negative 147. Okay. And then we need to do what? Take the square root of both sides. So let's go ahead and lay this out. I'm going to write it this way this time. Okay. So we know this is going to equal I. Is square root of 147, and does it come out to be anything? No. So let's go to our calculators. Let's go 147 divided by 100.
It's 1.
And 147 if we divide it by 49. So you just keep going down. So 147 divided by 49 is 3. So if we break it down, we have square root of 49 times the square root of 3. So we know that the square root of 49 is going to give us plus or minus 7. But we're still left with that square root of 3, and we also have the I with it. So we're going to have plus or minus 7, and I is going to be with that 7 because it's out of the square root. And then we have 3 left inside the square root. So that is our final answer. So on this one, we're going to, shut up. This one, we're going to add 1 on both sides. So that goes to 0. We're left with negative 2/3 x squared equals 16. Oh, 18. Yep, sorry. I've been used to subtracting this whole time. So 18. So when we're getting rid of a fraction, we do what?
The D word, I don't know what's good.
Not dividing. We multiply by, it starts with an R. The reciprocal, yes. Was that Clayton? Shout out to Clayton. So what's the reciprocal?
3/2.
3 over 2. So, multiply by the reciprocal on both sides, because whatever we do to one side, we do to... Yep, period. So, all of this cancels out, right? All of it cancels out, because it's 1, 1, 1, 1, you know? So, we're going to be left with x squared equals what? Negative, 18 times negative 3 over 2. I'm not looking at my paper. Yeah, negative 27. So, now we take the square root of both sides. Now, let's break it down. Hammer time. 27. So, when we're looking at 27, there's only a couple factors of...
3.
Yep. So, if we break it down, we'll have I for our square root of negative 1, and then square root of 9 times square root of 3. So, we know that the square root of 9 is going to give us plus or minus 3. And then we're still left with the square root of 3 inside. These are all still being multiplied, but now I and plus or minus 3 are on the outside. So when we write it out, it's going to look like plus or minus 3I square root of 3. So we're starting with I to the 1 power. So I to the 1 power, that means I... Oh, what? Why did I write it like that? That just means I, right? So it's just I. And then if we have I squared, that means we're going to have I times I, which is going to be negative 1. Now, we have I cubed, which is going to be, and you guessed it, I times I times I, which is going to give us negative I. And then the 4th to the 4th, you guessed it, I times I times I times I, which is going to give us positive 1. Now, yes, negative 1, negative 1. So it would give us a positive 1. So, here is something, yes.
Why does the 3I equal just negative?
Because it's like I times negative 1.
So it's just
Yes. Okay, so over here in this little section right here, you are going to write the pattern. Why is it being weird? Pattern repeats every 4 powers. So these 4 are what you base everything off of. So if that is the case, what are we going to have for I to the 5th?
1I.
Just I, right? If it repeats every 4th power, that means I to the 5th is going to be equal... Oh, that wasn't my little thingy. But I to the 5th is going to be equal to I to the 1. I to the 6th is going to be equal to I squared. So that means we're going to have negative 1. It's just going to keep repeating. It's the same rule. So it goes by 4s. It goes by 4s. And I'll show y'all that example when we get to right here. So you can write it out if you want to. You can write out I times I times I times I times I, but you would see negative 1 times negative 1, and then you're left with 1I.
So what would that be?
So it would just be a positive 1 because negative 1 times negative 1 is positive 1, and then all you're left with is I. So that's why you get that I, right? Does that make sense? Okay.
So 13 be negative.
Yes, but we'll get to that in a second. Yes. If we're looking at I to the 15th power, what we're going to do is we're going to take 15 and divide it by 4. So, take your calculators.
Oh, you got
That's a shame. Why don't you?
it.
15 divided by 4 is going to be what? 3.75. So, 4 times what? 3, which is what you got. 3.75. So, just do 4 times 3 is going to be 12. So, 12, 15 minus 12 is going to be 3, right? That's the closest thing, the closest multiple you're going to get of 4 to 15. So, you're going to divide the exponent by 4, and you get 12, right? I mean, you get 3.75, right? But the closest thing that you can get to, so like, let's take it back to elementary real quick, actually. Let's take it back to elementary really, really quick. So if we have 15 and we have 4 needs to go into 15, how many times does 4 go into 15? 3 times, right? 12. The remainder is 3. This is really how I should have done it. Remainder is 3. So, what is I to the third? Negative I. So, I to the 15th is going to be equal to negative I.
Well, 3.75 is 3.3.
Okay, but at the same time, we just need to look at the remainder. This is what we're worried about, is the remainder. That's what's going to give you your answer that's equivalent.
3/4 is the third option, right?
So now if we're doing 62, we need to do 62 divided by 4. Do y'all want me to do the long division? Okay, smarties. So, if it gives us 15.5, what is our remainder going to be? 2/4 equals 0.5, correct? So, our remainder is going to be 2. I like this. This is good. This is good. If people can remember that. We know 50 cents is 2 quarters, 4 quarters and $1. 50 cents is 2 quarters. Yeah. Okay. So if our remainder is 2, then we have I of 62 is going to equal what? Negative 1. Because I squared equals negative 1. So when we're doing this, let's go ahead and multiply the coefficients first. What's 4 times 7? 28. And then when we multiply the i's, I times I squared. Now, if you look back up, what's I squared? Negative 1. So we're going to have 28 times negative 1, which is just going to give us what? Negative 28. So that is our answer. On this one, let's go ahead, multiply all of the coefficients. -4 in your calculator times 2 times 9 is going to give us what? Positive 72, because negative times negative, positive. Okay, and then we've got our i's, so it's going to be I to the what? I to the third. What is I to the third? Negative I. Why did I do it like that? That looks like... So now we're going to have negative 72. Let's bring the negative to the front. Negative 72, I. And that's it. This one, we have to do... Yes. So we have to go ahead and just bring that exponent to each of these. So what's 2 cubed? 8. And then we have I cubed. And then we just have the 5I. So then let's multiply our coefficients. 8 times 5 is 40. And then our i's is going to give us I to the 4th. Right? So I to the 4th is 1. So our answer is just 40. For this, we need to bring that exponent to each one. So when we square a square root, what does that do? It cancels it out. So the squared and the square root cancel out, and so we'll just be left with 3. I know that might seem a little confusing, but you will get used to it. So I is going to be squared, but 3 is just going to be by itself now, because the square and the square root cancel out. Even if you put it in your calculator, if you put in square, do it all in parentheses, square root of 3, parentheses, all squared, it's going to give you 3. So, times, do the same thing. Now, when we square a negative number, it's going to be positive. Let's remember that. Because when we have plus or minus 8, because we have a square root of 64, y'all remember when I said negative 8 times negative 8 is going to give you that positive 64, and that's why we do the plus or minus. Remember? Does that make sense? So that's why when we square that negative 8, it's going to give us a positive 64. So then we also have that I that's squared. So let's multiply the coefficients first. So what's 64 times 3? 192. And then we're going to have I to the 4th, right? Which is just 1. So 192 times 1 is just going to be itself. So our answer is 192. This one? Yes. We're going to break it down first, because if y'all remember on the step 1, I'm actually just going to break this down real quick. So, negative 1 times positive 18. I'm going to just do the parentheses so that we know we're multiplying that specifically. And then this one is going to be its own specifically. Does this make sense? I kind of just split them up, just like we were doing, because this is our A, this is our I, right? This is our I, this is our A. So, we know that we're going to have I square root of 18 times I square root of 10. Now, what do we think is our best option here? Bro, we gotta stop with the gulping. So, yes, so, but what I was going to suggest is we go ahead and multiply these, because we can multiply square roots. We're just, yeah, 180. So we'd have I squared, right, on the outside, and then we'd have 180 on the inside. So now we've got a bigger number to break down. So now we just go through it and we start dividing from the top of the perfect squares to the bottom of the perfect squares. So let's divide 180 81. Oh, no, that's not it. 180 divided by 64. Oh, that's not it. 180. Nope, because then we got 4 and 5. So, well, then what did you say? It was 9 and 20? So then what's 9 times 4? What's 9 times 4? 36. So let's divide 180 by 36. Okay, that's 36 times 5. So square root of 36 times square root of 5 is going to give us 180. So if we've got the square root of 36, it's going to be plus or minus 6, right? But then we still have the square root of 5. And we still have our I. So we're just going to bring it out as 6. And then what is I squared?
-1.
-1. And then we have the square root of 5. So our final answer is just going to be -6 square root of 5. And if y'all remember, we're not going to need that plus or minus in front of it because we are not solving an equation. We are just, what did they call it on here? Simplifying the expression. So there was no need for the plus or minus because we were just simplifying this expression. Does that make sense? We need to do our first step where we break this down. -1 times square root of 24 times square root of -1 times square root of 3 times square root of -1 times square root of 2. Now, that means we're going to have 1, 2, 3 i's, correct? I cubed. Now, let's go ahead and multiply all of these. So 24 times 3 times 2. Square root of 144. Now, it's 12. What is I cubed? Negative I.
-12.
And then we have 12. So it's just going to be -12I is our answer. Okay, if you didn't grab both sheets, you should have, oh no.